Alright, so the question asks about a string that is wrapped around a uniform solid cylinder and has a radius r. And this cylinder can rotate basically freely around this axis in the middle, and it's attached to the string with another mass on it that is equal to the mass of the cylinder itself. So the question wants us to find the magnitude of A, which is basically the angular acceleration on the cylinder, as this block basically descends. So on the cylinder itself, um, the force diagram would basically look like mass, gravity, but then like this beam would also hold it up. But the important thing here is this torque on the cylinder caused by this mass hanging here. And that's what we really want to look at here. So some big ideas in this problem would include rotational motion, in translating basically 2D, 1D, linear motion, as you might say, to angular motion. Another big idea would be using the moment of inertia, which would be just like mass for angular motion. Um, and different shapes have different moments of inertia. And finally, one big idea here would be the idea of torque. Basically, what would be like force when we were looking at linear motion. Um, so yeah, to solve this problem, there are a few things that we want to do. So one of the things that we want to do is we want to write down what we know to be true, basically like the given in this sort of question. So we know that MA equals mg minus t, um, and we know this to be true when we sum the forces on the block. So another thing we know to be true is that the angular acceleration equals minus a times r. Um, that is something we just know to be true, and we also know that basically the torque times this radius times the radius is equal to the moment of inertia times the angular acceleration. Basically taking from the idea of linear equations and using the angular momentum and the angular counterpart. So doing this, what we can do is we can basically substitute in for A. Um, and here I basically substitute in for A, RA. And what this allows us to do is we can only have angular acceleration, which is good for us, which is something we actually want to solve for, right? So by doing this, we can solve for the angular acceleration. So here, the masses all cancel out. Do a little bit of algebra to get minus g equals 3 over 2 angular acceleration times r. Notice the negative sign here because it's in the negative direction when we're looking at angular motion. So eventually we get the answer, doing a little bit of algebra down there, of minus g over 3 over 2r equals the angular acceleration. And are a few common mistakes with this sort of problem. One of the most common mistakes is using the wrong signs. And basically, a lot of people might get confused with the way angular signs work out, and they might use the wrong ones, which might not be entirely correct. So another common mistake here would be converting this angular acceleration to linear acceleration incorrectly. And that can be a really common mistake if you don't know basically the relationships between the two. Thank you.